The universe has a dark side. Space is beautiful, but beauty out there hides something far more haunting. Beyond the glitter of stars and the calm swirl of galaxies lies a universe that is vast, indifferent, and sometimes terrifying. A place where light can be swallowed whole, where worlds drift through endless night, and where the very fabric of reality begins to tear. For all its wonder, the cosmos has a dark side, one that humbles even the brightest minds who dare to look too deeply into it. Imagine standing in the middle of infinite emptiness with no stars, no sound, no horizon. Or witnessing a burst of radiation powerful enough to erase a planet before you could even blink. 4. Imagine falling into a place where time slows, light bends, and every law of physics you've ever known simply stops working. These aren't scenes from science fiction. They are real places scattered across the universe we call home. From vast cosmic voids that stretch for hundreds of millions of light years to invisible forces that tug at entire galaxies. From dying stars that unleash unimaginable energy to the edges of the universe itself where light can no longer reach us. So let's journey into the places where even light fears to go. This is the most terrifying places in the universe. The Boötes Void, the great nothing in the vast map of the universe. There are places filled with light. Clusters of galaxies, stars, and nebulae painting the cosmos with brilliance. And then there are places where the universe seems to have forgotten to exist. One of those places is called the Boötes Void. A region so enormous, so empty that astronomers simply call it the Great Nothing. It lies about 700 million light-years away in the direction of the constellation Bootes. At first glance, there's nothing unusual about that patch of sky until you look deeper, because within that region spanning nearly 330 million light-years across, there are almost no galaxies at all. To understand how strange that is, consider this. If the universe were an ocean of galaxies, the Boötes Void would be a hole large enough to swallow tens of thousands of Milky Ways and still have room to spare. It's not just a gap between clusters. It's an entire region of the cosmos where matter itself is missing. Astronomers discovered it by accident in the 1980s while mapping the distribution of galaxies across the sky. Where they expected to find countless points of light, they found nothing. A hollow so vast that it challenged our understanding of how the universe is structured. The universe, as we know, is woven together in a cosmic web. Long filaments of galaxies stretching across space, separated by dark voids. But even among these voids, the Boötes Void stands out. It's more than twice as empty as typical cosmic gaps. In its center, you could travel hundreds of millions of light years in any direction and never encounter another galaxy. Imagine being inside it. There would be no stars, no galaxies, no Milky Way shining faintly in the distance. Only darkness. The nearest light might take hundreds of millions of years to reach you. Even the cosmic microwave background, the faint glow left from the Big Bang, would look dimmer there. Some scientists believe this vast emptiness formed naturally as the universe expanded, a byproduct of how gravity and dark energy shaped space over billions of years. Others suggest something stranger, that the Boötes Void might not be a single empty region at all, but the overlapping result of multiple smaller voids merging together. An emptiness born from other emptinesses, creating a cosmic desert beyond comprehension. And yet, some theories go even further. A few physicists once speculated that regions like the Boötes Void could be the scars of cosmic collisions, remnants of where another universe might have brushed against ours long ago. While there's no evidence for that yet, the idea adds an eerie weight to what we see, that this might be a mark left behind by something far beyond our own reality. What makes the Boötes Void so haunting isn't just its size, it's what it represents. A reminder that most of the universe is not stars or galaxies. It's emptiness. For every cluster of light, there are vast oceans of darkness in between. If you could stand at the center of the Boötes Void and look around, you wouldn't see a single star. You would see only blackness in all directions. And perhaps if you waited long enough, you might see a distant galaxy flicker faintly, a single spark in an eternal night. In that silence, surrounded by nothing, the universe would feel truly infinite. The Boötes Void isn't just a hole in the universe. It's a window into what most of the cosmos really is. Not stars, not galaxies, not life, but nothing at all. the Eridana supervoid. If the Bose void is a hole in the universe, then the Eridana supervoid is something even stranger. A wound. It's not just a region of emptiness, but a cold mark on the very fabric of the cosmic microwave background. The afterglow of the Big Bang itself, a place where the universe's earliest light runs cold. Astronomers first noticed it in the early 2000s while studying the sky using data from the WAP and later Planck satellites. When they mapped the temperature of the universe's background radiation, the faint uniform glow left over from its birth, they found something deeply unsettling. Amidst the near-perfect smoothness of space, one spot stood out. A cold spot hundreds of millions of light-years across, colder than anywhere else in the observable universe. That coldness meant that somehow there was less energy coming from that part of the sky. Something was sapping the cosmic light as it passed through. And when astronomers looked deeper, they found that the cold spot aligned with a vast region nearly 1 billion light-years wide, a place with far fewer galaxies than anywhere around it. They called it the Eridana supervoid. To understand why this is so bizarre, we have to remember that the universe's structure, the cosmic web, is a delicate balance. Galaxies cluster along invisible threads of dark matter while between them lie the voids, the empty spaces. But the Eridana supervoid isn't just another empty bubble. It's too big, so large in fact, that our standard models of the universe struggle to explain how such a vast underdensity could even exist. If you could drift inside it, you'd be entering a realm where galaxies thin out until there are almost none. Starlight would fade. Cosmic radiation would drop. The sky would grow quieter. Not because sound doesn't travel in space, but because there would be nothing left to make noise, and it's cold. Not in the sense of temperature you could feel, but cosmically cold. Photons from the Big Bang lose energy as they climb out of this gravitational emptiness. The deeper the void, the colder the light becomes. It's as if the universe itself shivers when it passes through. But what truly unsettles scientists isn't just the emptiness. It's the possibility that it might not be natural. Some have suggested that the cold spot could be the bruise of another universe. An imprint left when our cosmos collided with a neighboring one during its earliest moments. If that were true, the Eridana supervoid could be evidence that our universe isn't alone. That beyond our cosmic horizon, there are others pressing against ours like bubbles in a multiversal sea. Of course, not everyone agrees. Many researchers believe the cold spot is simply a statistical fluke, a coincidence in the random distribution of cosmic background radiation. But the numbers don't quite add up. It's too large, too deep, and too distinct to dismiss easily. So, we're left with uncertainty, a void that refuses to give us answers. Either way, it stands as one of the strangest and most haunting features in the universe. A vast cold scar on the sky, marking the place where the universe itself might remember its first collision. The great attractor all across the universe, galaxies are moving. Some drift apart as space itself expands, while others swirl around clusters bound by gravity. But when astronomers map the motion of nearby galaxies, they notice something deeply unsettling. A mysterious gravitational pull drawing everything toward one hidden region of space. Our own Milky Way is part of that motion along with billions of other stars, planets, and galaxies. We are falling not through space, but with space toward a place we cannot see. A place known as the Great Attractor. Located roughly 200 million light-years away in the direction of the constellations Norma and Centaurus, the Great Attractor is one of the strangest features ever discovered in our cosmic neighborhood. It's not an object, not a single black hole or galaxy cluster. It's a region, a concentration of mass so immense that its gravity is pulling entire clusters toward it, distorting the flow of galaxies across hundreds of millions of light-years. Even our local group containing the Milky Way and Andromeda is racing toward it at over 600 kilometers per second. That's more than 2 million kilometers an hour. Yet, despite this enormous motion, we still have no clear idea what's actually there. The reason is simple. The Great Attractor lies hidden behind the thick disk of our own galaxy. This area of the sky is called the zone of avoidance. A region veiled by gas, dust, and starlight that blocks our view in visible wavelengths. It's as though the universe placed a curtain between us and the thing pulling us in. Through X-ray and radio telescopes, scientists have begun to peer behind that curtain. They found the Norma Cluster, a massive collection of galaxies rich in dark matter and blazing with hot gas. But the pull we feel is too great to come from this cluster alone. The gravity extends far beyond it, suggesting that the Great Attractor might just be a small part of something even larger. The Lania supercluster, the enormous structure that houses our own Milky Way and thousands of other galaxies. In this vast cosmic landscape, galaxies are not stationary islands. They move in gentle coordinated flows like leaves caught in an invisible current, all drifting toward one point of unimaginable density. It's a haunting thought. We are all passengers on a cosmic river heading toward an unseen destination. A journey not of our choosing toward a place we cannot observe and may never reach. And beyond the Great Attractor lies something more colossal still. The Chappelli supercluster, another gravitational giant that may continue the pull even farther into the darkness. If the Great Attractor is the first hand tugging us through the void, the Chappelli concentration is the second, drawing everything deeper into an unknown cosmic abyss. What makes the Great Attractor terrifying isn't just its size or mystery. It's the realization that our galaxy, our stars, and even the space between them are being carried along by a force we cannot resist or understand. We are being pulled not toward danger, not toward safety, but simply toward the inevitable. And one day, billions of years from now, this silent motion will continue. The Milky Way and its neighbors will merge, drawn onward into the flow of Lania. While the rest of the universe expands away, fading into darkness, the Great Attractor will remain hidden, unreachable, its gravity silently shaping the paths of galaxies that will never know its name. It is the invisible pull of destiny, the quiet hand of gravity, guiding us into the unknown. Magnetars, the star demons among the most extreme objects in the universe, are those born from death, the corpses of once mighty stars. But while most stellar remnants fade quietly into darkness, some return with a vengeance.